Hello, we are looking at vectors in 3 dimensions, and not that bad if I do say so myself. Let's get right to it. So, we've traditionally looked at just the x and the y for vectors. And indeed, much of our graphing to date has just been in 2 dimensions. However, there is a third dimension that we all live in, and that can be identified as the z-axis. So this is normally how you will see the three different axes presented. Note that the y now is going to the right, and the z is going up. Usually you see y going up and x to the left and right. Your horizontal is done by x. It still is, but now the x is kind of coming out of the paper at you. That is one of the limits that we have here in working with a two-dimensional space, so this video that you are watching right now, or the paper that you could be writing on. So it's replicated here, that leaping out of the page, by pointing it kind of down at you, like right here. As far as how we represent vectors, they are done with 3 coordinates. So you've got your A, which in this case is our x, your B, which would be y, and your C, which would be z. And how this could look would be something maybe like this. Okay, this is how you might see the vector, and you can actually project it down below onto just the xy. So this is just the x and the y down here, but you can connect it up to the three-dimensional part right there. So this is really where the z comes in. Down here, this is just your x and y. So they can look a little bit tricky to represent, but after you've done a few of them, I think it'll look a little bit more natural. Again, as far as how we represent them, over here you can use that as an algebraic vector, or it is totally acceptable to call this vector AI plus BJ plus, and then CK. Okay? You've got I, J, K. These are the ways that we represent those unit vectors that are for the different planes that we're working with, the x, the y, and the z. So what can we do with these? Well, let's say that we've got 2 vectors. I've got u and v. I want to add these together. We simply do this the same way that we were working with two-dimensional vectors. If I've got -3 and 2, I'm adding them together here. That would give me -1. 5 and 4 together give me 9. And then 8 and -6 would give me -2. Therefore, u plus v would give me -1, 9, -2. What if I'm using I, J, and K? Simple. Same thing. Add your i's together, your j's, and your k's. That's it. So we can add vectors like that, and we can also find out the magnitudes. It's a little bit more complicated, but not much once you get used to it. So I've got a vector here, W, that has the components 3, 4, and 7 for its I, J, and K respectively. What is the magnitude? Well, let's look at just the x and y component, which is down here. And the magnitude of this, we've said in the past, all I'm working with right now is 3 and 4. So that would be the square root of 3 squared plus 4 squared, which would give me the square root of 9 plus 16, which is the square root of 25, happens to be 5. Yay! Nice number to work with right there. Okay, so this is 5. The length of that is 5. So, but what I want to do is I want to find the length, the magnitude of this blue vector. I don't know what that is right now. But I've got my z dimension that I can factor in now. And the length of that, the magnitude of that, is 7. So now really, if I cut the triangle in a little bit different angle here, I've got something that's going to look like this. This hypotenuse, I do not know, but I do know from down here that the red was 5 and the green was 7. So the magnitude of the original vector in blue, W, is just going to be 5 squared plus 7 squared. Take the square root of that, which would give me 25, square root of 25 plus 49, which equals the square root of 74. There we go. That's that side. But that seems like a lot of steps. I have to get one side and I have to get the other. Well, check this out. I have this 5 right there, which I originally got back over here, but then I took the square root of that. What if we don't take that out of the square root, out of the radical? What if we said, okay, I'm going to set this equal to the square root of 3 squared plus 4 squared. We know this is 25. We're going to use this again right up there. So why not use the 7 squared down here as well? And what we'll see is that this gives us the exact same thing. What this will be is the square root of 9 plus 16 plus 49, which is the square root of 25 plus 49, which is what we had right back there. The same thing. So if you're finding the magnitude of a vector v, and let's say v is a comma b comma c, that's just going to be a squared, the square root of a squared plus b squared plus c squared. That's it. You don't have to go through multiple steps. That will give you your magnitude in 3 dimensions. All right, take a look back, see if you have any questions, and let's just briefly find the magnitude of another vector here, u. Let's say that u is -2, 6, 8. Find the magnitude of u.